Hi, this is Chi Hong Edmund Chan for BIT 265, and I'll be going through the addition for linear probing, finding with quadratic probing, and removal with double hashing. So our key in our case is 17. The table is down here. The table size is 5. And I've just added some numbers, some data into the table at hash index 0 and hash index 2. So we're going to start with linear probing right now, just here. So our key again is 17, and then we always start when I is equal to 0. Next, we calculate the hash. So the hash is always the key mod the table size. So in our case, it's 17 mod 5, and that leaves us with 2. So we know our hash is going to be at 2. And we've done that. So that's where we start here. We check to see if that's been occupied, and it is occupied. Therefore, we're going to increment I by 1 now. So we can't put it in hash 2, we're going to put it in 1. And we're going to start the process again, right up here. So key is still 17, hash is 1 now. Hash the key, which will still be 2, but now we're going to add 1. So now our value is 3. So we go to check if index 3 is empty. It is empty. So this is where our value 17 will go into. And that's just a quick run through of the addition for linear probing. Okay, we're back. And this time we're going to be finding the key, which is our key 17. And we're going to be using quadratic probing in order to do that. So first of all, here's our code. We've even got our constant values, which is C1 and C2. I'm going to use the same values that Mike used. So C1 is equal to 3, and C2 is equal to 5. So our key is equal to 17. That's the value that we're looking for. And I always starts at 1. Hash the key. So 17 mod 5 equates to 2. So our hash is 2 at the moment. And now we're going to plus C1, which is 3, multiplied by 0, which equals to 0, plus C2, which is 5, multiplied by 0 squared, which is also 0, and that leaves us with 0. So 2 plus 0 equals 2. And then we're going to do one more thing where we're going to mod the table size so that we get a value that's going to match, that's going to be within here. So we're going to do 2 mod 5, which leaves us with 2. Check the index at 2. We notice that it's not 17, so we know that that doesn't work, and therefore we're going to increment I by 1. So now I is 1, and we go through the code again. Just change that to 1. So now it's going to be hash the key, so that's 2, plus C1, which is 3, multiplied by I, which is 1, so that equals to 3, plus 5, multiplied by 1 squared. 1 squared is 1, 5 times 1 is 5. So now we're going to do 2 plus 3 plus 5, that equals to 10. And then we're going to again mod the table size. So 10 mod 5 leaves us with 0. So we're going to check to see if hash index 0 is the value of 17. So we know that 21 is not. We check, see if 10 is equal to 17. It's not, so we know it's not there. And then again, we increment I by 1 again. So I is now equal to 2. Go through the table again, where I is equal to 2. So let me just tie this up. So now I is equal to 2. Hash the key is 2, plus 3 times by 2 this time, which is equal to 6, plus 5 multiplied by 2 squared, which is 4. So that's 20. So that's 2 plus 6 plus 20 is 28. Mod the table size, so mod 5, which leaves us with 3. So now we're going to see if 3 is the key that we're looking for. And 17 is exactly equal to 17. And there we go, we found our value 17. So next we're going to do double hashing. Okay, so this is the removal of 17 with double hashing. Let me just clear this up a bit. So this time in particular, we have a second hash function to help with the randomness in finding an index, to search for the index in which to remove 17. Just going to put 17 back in here in slot 3. So yeah, let's go ahead straight away. So again, we start when I is equal to 0 right here. Our key that we're looking for to remove is 17. I value is 0. So first of all, we hash the key, which is 17. We should know what the value is. 17 by multiply 5 leaves us with 2. This is equal to 2 plus I, which is equal to 0. And this is our second hash function here. I've just used the same value that Mike used, where this time I'm going to take the key and multiply the value 17. So our key is 2 mod by 17, and this leaves us with 2 as well. So now we're going to be doing 2 plus 0 is 2, multiplied by 2 gives us 4. So, and then we're going to do 4 mod the table size, which is 4 mod 5, leaves us with 4. So first of all, we're going to check index 4 and see if it's empty. See if it says the value 17. We see that it's empty, so it's not there, and we just carry on with our code. So let me just tidy this up a bit. Oops. Get rid of that. So next thing we do is, again, as before, we're going to increment I by one, so that I is now equal to 1. So I is 1, looking for 17 again. And again, hash the key. So hash 17 is 17 mod 5, which leaves us with 2. Plus I, which is 1, so that equals to 3 now. Multiplied by hashing this key again by 17. So again, 2 mod by 17 equals 2 again. So this will be multiplied by 2. So it's 3 times 2 is equal to 6. 6 mod 5 leaves us 1. So we're going to check this location here. We see that that's also empty, and that's also not the value that we're looking for. And again, we just keep going. So let me just clear this out now. Increment I to be 2 now. And we start again. So hash of the key, oops, did not want to do that. So hash the key is 2 plus 2 this time, because 2 is equal to I, as we know from here, multiplied by, take the key and mod it by 17 with the second hash function. So 2 mod 17 leaves us with 2. So now we're going to do 2 plus 2 is equal to 4, multiplied by 2 is equal to 8. 8 mod 5 leaves us with 3. So we're going to check index 3. Is that the value that we're looking for? It is 17. So we remove it, and we now put in here empty, but was occupied by 17 until we removed it. And that's my run through of linear probing, quadratic probing, and double hashing.